Danger, electric shock risk, but there is something much more dangerous in this video. It's not revising. That's why I've made these videos, so you can revise easily from it. So let's get into it. So voltage, current and resistance. Voltage, current and resistance. Metals can conduct electricity. I will also be conducting electricity during this video to show you how it works. So, two types of circuit. Series circuit and the parallel circuit. So the series circuit, all the components are placed in the same loop. The current at any point in it is the same, and all components have to not be broken. So basically, if one of those bulbs was broken, the actual current couldn't travel through the entire thing. The actual anything couldn't travel through the entire thing. It wouldn't be a full circuit anymore. It would be broken. However, a parallel circuit is placed in separate loops. The current is shared between each component. One component can break and the circuit can still continue. This is as there's still one loop. Say the one in the middle broke, say that bulb broke, it could still go around the other way. It would still make up an entire circuit. So basically, in a parallel circuit, the total current entering a junction was the total current leaving a junction. So that means this side here will be the same as the addition of the two things leaving it. So, we've been talking about a lot of current currently. So, what is current? Electric current. So, let's move on to it. So, current is measured by an ammeter, which is in amps. That is a picture of an ammeter on a circuit diagram. The electron flow is of an electric current is from minus to plus, and the conventional current is from plus to minus. The electric current is basically the flow of charged particles, which are, well, also known as electrons. How much will I charge for this video? Not much, so let's charge ahead to charge. So, charge is measured in coulombs, which is C. It's an example of charge is charge of electrons, which is minus 1.6 times 10 to the power of minus 19. Yeah. So charge is basically the strength of an electric or magnetic field. So charge can be positive or negative. The same charge repels, and the opposite charge reflects. Or attracts. That's probably what I meant to put. Anyway, what links together charge and current? So, charge in coulombs equals current in amps times time in seconds. So basically, the charge is the amount of current times by the amount of time. So the charge goes up with the time, but the current stays the same. So, potential difference voltage. So that is the push that a cell or power supply gives to electrons, which makes them move around the circuit. So basically, it's the actual force behind making the electrons, charged particles, move around the circuit. So it makes everything move, basically. It's in volts, which is V. A voltmeter looks like an ammeter, but with a V in the middle. It's always set in parallel. So if you want to put in a voltmeter, you set it in parallel on a circuit. Voltage and current are directly proportional, which means the more voltage there is, the more current there is. And in a series circuit, voltage is stored between components. That basically means that the components is shared, so the voltage is shared between the components, so it's split up. They don't all get the same amount. However, in a parallel circuit, the voltage is the same in each branch, which means the voltage never goes down. So voltage will be exactly the same for everything, as high as possible. So, we've got voltage and current. How do they link? So, they link because of something called resistance. So, resistance is measured in ohms. That's the sign for ohms. Resistors in series add together. So, resistors that are all in the same circuit, in the same loop of the circuit. Measurement of, basically resistance. What do you think of when you think of resistance? I can't resist going into this, but it's basically the force stopping something, isn't it? Resistance is power against something, so that's exactly what it is here. So the measurement of the difficulty encountered by a power source when forcing electrical current through a circuit. So it basically shows us how much is against the push of it, how much is stopping it from working properly. So the resistance equals the voltage divided by the current, which is Ohm's law, which is R equals V over I. Current is called I. Basically, the resistance equals voltage divided by the current, as the voltage is the push given, and the current is the amount that actually starts off with. So the resistance is how much is cut off that, which we can find out using this. So say the voltage was 8 and the current was 2, then the resistance would be 4, because 8 divided by 2 equals 4. It's an example of Ohm's law. Resistance factors. So some things about wires change the resistance. So the more thick a wire is, the less resistance it has, as there are more routes for the electricity to follow. The more length of a wire, the more resistance it has, because there are more collisions between the different particles. Also, the lower temperature equals to less resistance, as the plus ions don't vibrate as fast, because the plus ions are holding back the minus electrons. So the LDR, light dependent resistor. So basically, the more light you give to it, the less resistance it has in the long run. And yeah, that is the symbol for it in a diagram. So the more light, the less resistance, the less light, the more resistance. It's used in things like lights that only turn on at night, that sort of thing, because that's how it works. So a thermistor, higher temperature equals less resistance. So the more the temperature goes up, the less resistance the electricity has. These temperature regulators are often used in stuff like things that heat a house and stuff like that. So resistance. Well, that was over there. I was just reading that. Gradient. Gradient is used for graphs. So y squared minus y, not y squared, y2 minus y1. So that's the second value of 2 minus the first value of 2. So the final value minus the initial. And the same for x. We divide it. Gives you the gradient. And on this diagram, if you have voltage there and current there, then the gradient equals the resistance. This is because, well, resistance equals voltage divided by current. So voltage divided by current, the gradient would be resistance, as the voltage is that, y, and the current is x. There. So that was electricity. Don't mix water and electricity, kids. That was voltage, current, and resistance. Goodbye.